It gives me unbelievably great pleasure to introduce my friend and colleague, Jens Monig. Jens, as you all know, is the author of Snap. He's a researcher at SAP. He is a Renaissance man. He's a musician. He's creative. If you ever can't believe that programming is creative, you need to watch what Jens is going to do. And it gives me great, great pleasure to introduce Jens, who's today going to talk about Hyperblocks, the great new feature that he's going to show you all in Snap 6. Welcome, Jens. Let's give him a hand. Jens! Woo! I will stop sharing and yield the floor to my friend. It's all you, my friend.
Thank you, Dan. Thanks to everybody for coming. Wow, this is crazy. I've got my screen. I've got several screens full of friends, of people I know, and some I don't know. And I have to confess that I've been up very late last night because I'm so excited about this. I'm actually going to share my screen. Okay, I have to remember to also share my computer sound. Okay, I'm going to share my screen, and okay, here I'm in Snap. I did prepare a couple of slides. I'm not sure I might actually not do them. So this talk is about the new version of Snap, which is somehow a point of completion we feel of kind of the last year. We were kind of caught off guard last summer by Chrome becoming unstable, and we really needed to rewrite large parts of Snap to make it stable again and to make it scale. And this is kind of what we're trying in this new version 6 release, to grow Snap, to make it handle bigger projects, to make it run faster, and to make it do kind of more things that have a sense of reality. So this is something that we feel is a motivation. We want to prepare students for the real world, and what does it even mean? So last night, as I was kind of procrastinating, I had a look into my old ancient Webster dictionary, and there's lots of stuff on here that's very philosophical, very ontological, and actually, when I read down to the fourth meaning, it all made sense. Real, you pronounce it real, and it was once the chief former monetary unit of Spain. So here's a real. So it's money. It's something you can get paid by. And this is actually funny. So this one I got is not real. It's fake. But boy, if it were real, I'd be able to trade it in for like 10 hamburgers. In this restaurant in Minnesota. And lots of things kind of make sense when you think of real as something that you can touch, but you can also make money with. For example, many things about programming, like how can I use my old computer to make money? Or like even if I'm this Ebenezer Scrooge impersonating Abe Lincoln cosplayer, there's real world functional programming in the pipeline for me. And very often kind of this other dimension of realness is kind of this physical world where something can be touched. And there's all, here's a company from Malaysia that has got this all covered. This is their collection of robots. It's actually an ascension. It starts with pre-K with a small robot. Then it goes up to middle school. There's 2 levels of university level robots. And I kind of get the impression that as the bots grow, growth mindset is somehow transferred to the students. So we prepare them for their hands-on jobs later. Except that many of the things we've already experienced in the real world aren't really so hands-on. Like even physical things like, the Super Bowl, like sports events, we often get them second-handed, so by watching TV. Many of the things that affect us very directly, like politics, we get from reading the news or online or an actual printed newspaper. And I sure stayed up very late to watch the live video stream of the Falcon 9 flying out to the ISS. All of this, I wasn't there in reality, but I was reaching this through media. And, lastly, we're all here at this online conference because things happen in reality that we can't see, that we can't go out and kick, but they still affect us, and it needs science to explain this to us. So all of this is basically media. Media kind of connects us to what's happening. And this is something that I fell in love with a while ago. It's really kind of the pedagogy that Mark Gusdale and Barb Erickson kind of invented to teach general purpose programming by looking at media, because that's just so very relevant. So this is kind of an approach that we followed for the last 2 years. And the way Hyperblocks happened is through a mistake that we often saw. So actually kind of right before this COVID crisis, when we were, Jadka and I were in Erlangen, hi people from Erlangen, talking to some teachers, and we often kind of start by saying, you know, in Snap, you've got the plus block, you can get 3 plus 4, you get 7. And what if you have a list? And so say we've got a list of a bunch of numbers. And so what if we want to apply the 3 plus blank block to every item of the list? And we ask them, and usually somebody comes up with the idea of taking programming is all about. And then we ask, you know, do you know any other way? And you know, we kind of press them hard, and sometimes somebody knows, and usually we just end up showing them the Snap way, which is we use map. No loop, we use map, and we just do it in a single statement. But in Erlangen, as every other time, sometimes there is somebody who carefully asks, can we do this? And we say, no, not really. You see, because plus, the domain of plus is numbers. And so here's a number and a list. And if we click on this, it's, we don't know what to do with it. It's a mistake. It's not a number. And the more these things came up, the more I remembered that actually 10 years ago, Brian and I sat in Brian's basement and were leafing through some old APL manuals, because Brian told me the story how when he was 14, Ken Iverson was one of his mentors, and he fell in love with APL, and APL was able to do just that. So this is kind of the big new feature, aside from making things faster, that in the new version of Snap, now we have Hyperblocks, and I just turned it off for this demo, so I'm turning it on as it is for all of you. And with Hyperblocks, now this makes sense. And notice that where heretofore you used to get an error or something that you probably didn't want, we're trying to make sense of something that is almost naive. So we can add a number to a list. We can also have 2 lists. Let's see, this is 40. And so now we have a dyadic function, and we're trying to find items that correspond. So here 4 items correspond. So we add the first item of the left list to the first item of the second list, and so on. So we basically expanded the domain of monadic and dyadic functions from scalars to lists and tables to vectors and matrices and multidimensional data. So this also works with many other functions, many other reporters. Here's the numbers from 1 to 10 block. And so these are also numbers. What if we put another list of numbers in here and we click on it? Wow, we get a table. What if we put it here? We get another interesting table. And also another feature is, as we can right click on anything to get a blockified version of that table, of that list, and we can see kind of that the blocks in here resemble the result. It also works with things on strings. For example, here's a Unicode of a block that gives us a number. If instead of just a letter, we write in a story like the quick brown fox jumps over the lazy dog. So instead of and as a list, we can apply an arithmetic function to it, the times block or the plus block, and just add 3, for example, to every number. Now we get another list of numbers. This also works for the inverse function. Here's Unicode of a number as a letter. We get a letter. Now, if we pass in a list of numbers, we get a list of letters. So once we have a list of letters, we can just concatenate them using join, and we got another word, an encrypted word. And this is basically like a Caesar cipher. So we could turn this into our own block and say, encrypt a text with a key. And this is a reporter, and text is going to be an input, and key is going to be an input. And we just put this in here, and key is going to come first, and text is going to come second. So this is our encrypt block. So now I can give it a variable that's called secret. I'm going to set the secret to encrypt my story with, let's say, 5, the key 5. So now here's my secret. And kind of the beauty of this kind of way of thinking is we can use the same function to decrypt it again. So here's my secret. And if I know the key, I can just negate it. So this was not 4, it was 5. If I say -5, I again get the original text. Now, mind you, this is almost naively simple if you look at this code. Often kind of you do the Caesar cipher to introduce loops, to introduce variables, to introduce state and kind of encoding. But really the algorithm isn't all that spectacular. It's not, and it can be formulated in almost a naive way. So this is almost kind of the essence. Now let's apply to something more fun. Since this is the first Scratch conference in the US, let's actually start with America first. The Star-Spangled Banner. Let's see if, okay, so now I've got the sound. I'm gonna play the Star-Spangled Banner. Patriotic thing, I got the sound. And I can find out things about the sound. This is a kind of media computation. I can find out it lasts for 77 seconds. And I can also check the samples. So if I click on the samples, I get the numbers. And it's a list of 3.4 million numbers in between -1 and +1. And this is kind of one of the design principles, that numbers and lists of numbers are really just one block away from all of media. So if this is a list, we can just use our math blocks on them. For example, we could just say, okay, what if I multiply 3 with the samples? I get another list, and the numbers are slightly larger. So we're going to play that back. You might want to tune down your sound a little bit. Stop it. It's loud because we multiply it with more energy. Likewise, we can divide it by something. Let's actually divide it by 4 and listen to it. It's getting soft as the numbers are getting smaller. So this is the idea. It's just simple arithmetic. We can do things directly on data to find out interesting things. So here's another block in here. This is, for example, the greater than block. So what happens if I put the samples in here and I ask, like, if the samples are greater than 0? Now this is a hexagonal diamond shaped block. It's a predicate. And if I click this, I usually get true or false. But here I'm entering a list of numbers. So the result is a 3.4 million item list with falses and some trues in it, true and false in it. So I've basically gotten rid of all the nuances and just reduced it to, well, is it 1 or 0? It's basically an on and off, a 1-bit encoding. So ladies and gentlemen, tune down your volume. Here's George Boole and the Binary Brass Band's rendition of the Star Spangled Banner. Okay, turns out George Boole is Jimi Hendrix's younger brother. He kind of needs to play with his guitar some more. So simple arithmetic, we can do things with numbers because numbers are at the heart of media. That's kind of the idea. And this is where hyperblocks really help us get rid of all the loops, of all the state, of all the variables. Let's actually try to make sense of some data. I'm going to import something else, something real from my computer. I'm going to go into my music. The Wall, another thing that plays a big role nowadays. There is a song, it's Empty Spaces. Showing this in Finder. Here's the song. I'm going to drag this into Snap. Now it's in Snap. I'm just going to try whether I can play it. Empty Spaces from Pink Floyd. Not much of a song. Goes on like this for a while, and it works. Okay, so we can also look at the samples. I'm going to look at the samples of Empty Spaces from Pink Floyd. And here you see something interesting. It's not a list, it's a table. So a table, because it's a stereo song, so it has 2 lists. It has a left channel and a right channel. So right channel, that's the item 2 of the samples. Now I'm getting this list. I'm just going to look at this list. So how do I access items in a list? I use the item off block. So if I get the item 1 of a list, I'm getting a number. If I kind of type in any number that's within the range, that was outside of the range, I'm getting another number. I can also, since this is hyperblocks, put in a list of numbers. So I can get the second one, get some numbers, and I'm copying those numbers out of the list of all the samples. And if they're consecutive, I can use the numbers from toBlock. So for example, I can get the numbers of 600,000 to 700,000. Now I'm getting a list of, I can play this. Where it gets interesting is when you look at a certain part of the song that I've been chasing last night, and it's 3.150, 1112, 3.830. This is a bunch of samples that is interesting. Let's actually play this part of the song. There's some music happening here. Okay, that's not the really interesting part. Because what's interesting is happening in the other channel. It's happening in the left channel. So let's look at the other channel and listen closely. You'll hear something. Voices. I can understand what you're saying. So we want to find out what they're actually saying, these voices. So we're making a variable, clipping this, and I want to look at this part of the song. So I'm setting the clipping to this part of this. It's a list of numbers. So now clipping is the part I want to look at. And I want to, you guessed it, play this backwards, because I'm thinking that maybe YouTube and Google showed me that this is the secret behind the song, and I want to find that out. So if I get the numbers from 1 to 10, I get an ascending list of numbers. If I get 10 to 1, I get a descending list of numbers. So one trick I can do is I can get the length of the clipping that I made, and I count down to 1. So now I get a very long list that counts down all the way to 1. And I can use this as a selector. So I'm getting the item, counting all the way down. Now, listen closely to what we're hearing now.
Congratulations, you have just discovered the secret message. Please send your answer to Old Pink, care of Farms, Chalfont.
We're saying, congratulations, you have just discovered the secret message. Please mail your answer to Old Pink, and then there's some other voices. So we've just made sense out of some data. We've gone down to the numbers, we've manipulated the numbers, and we've kind of played it backwards, and the music actually didn't sound so bad. And all in this, we've also found out how to reverse a list. So we can actually generalize this and say, we're going to make a new reporter that is going to say reverse list. And I'm just going to do this. And instead of the clipping, and instead of the clipping, we're going to turn list into an input. And use this here. So this is the code that reverses it. Let's try it again once more. This is all the code we need. That was wrong, of course. This is the problem with doing things online, because it's counting up instead of down. So got into the wrong slot. Let's try it again.
Congratulations, you have just discovered the secret message. Please send your answer to Old Pink,
and so on. So this is something that is interesting. And look at the code. It didn't take us a lot of code, and most of it really is almost trivial, almost naive to think of. So none of the let's do a loop, none of the assignment problems, none of the state problems. It's an almost naive way of thinking about these things. So this was how we can use hyperblocks on lists. Let's actually try something else. I'm going to hide this. I'm going to make a costume, taking my webcam and making a picture of myself. I'm making another one of myself. Okay, now I got two pictures. They're called camera and camera 2. I can go and look at the costumes, can find out things about camera. But the most important things I can find out about the camera costume is the pixels. So if I click on the pixels, I'm getting a table. It's a table with 172,000 rows, and the columns are the color channels, red, green, blue, and the alpha channel. And I can get the same thing of the camera 2 picture. So it's also a table. And remember when we told you that we could use these operators, these functions, dyadic functions, on scalars, vectors, and matrices. So these are all matrices. So we can actually add the pixels of one picture through the pixels of another picture, and we get another table with corresponding values have been just added, and we can just show this. So now what I'm getting is actually kind of a double exposure, a picture where I've just, just added the pixels of two photos together, and it's even getting brighter because the colors are adding up. So we could kind of do something else. So now we've got this table, and we can average it by dividing it by 2. So it's a table, and we're applying a monadic function. And now we're getting this ghost picture of me with both hands raised, where I needed one to actually take the picture. And so this lets us actually do some interesting things. For example, there's another way to get a picture, which is I can get a video snap of I can snap. I can add it to the current costume. And I can do this all the time and average it. Now look what happens. I'm getting a motion blur effect on my live video. So here's kind of Alonso, drunk Alonso and Jens, a motion blur effect, kind of a, let me try to capture it. So this is a motion blur effect on live video. And okay, let's try one more thing. Switching again to the costume of the camera. And so here's the pixels of camera. And it's a table, but a table really is just a list of lists. So it really is a list. So remember, we just did the reverse block using Hyperblocks. If it's just a list, it should work on the pixels also. So what if I just switch to the reverse camera picture? Oh, I got an effect I'm turning upside down because now the pixels are all in different order. So I could actually use this for another little experiment, making a variable called pixels. So I'm setting the pixels to whatever the camera gives me. And then I'm just switching to the costume where I'm adding the pixels to the reverse pixels. Let's try this. So wow, look at this. I got myself a kaleidoscope where I'm mixing my current view actually of the camera with a rotated version of myself. And I'm again getting these double exposure effects. And this is all just with a couple of blocks. So maybe it would be interesting to actually also try to average this, and I can do this while it's running. So now kind of the quality is a little better. I can do fun things like I can try to, actually, let me try to align my eyes. Okay, so now I look like the abominable monkey man. This is kind of our idea. The building blocks of media are uniformly represented in Snap. It's as it should be in a digital environment, it's numbers. So we have numbers and lists of numbers, and tables are lists and lists of numbers, and we can just do arithmetic with them. We can just do math with them, to remix them, to manipulate them. But we can also do one more thing. We can make our own media. And I'm going to show you one way. You don't have to use this way, but another way that kind of doesn't use loops to actually create things. So remember the numbers from to block. So what if I get the numbers from 1 to 100,000? 100,000 random things. So I can map the numbers over the random function, and I want to get samples. So it's from -1 to 0.999, so I'm getting all the numbers in between. So now I'm getting 100,000 random numbers. There's no loop involved here. Map does it all. And I can play this. And since it's random numbers, you know what it's noise. It's noise. So maybe I don't need 100,000. Maybe I just need 200. So now listen. There's just a little click. It's random. It's just a little click. So what if I repeat this random noise a couple of times, like 300 times? So I want to again use map. But I can't put this in here because otherwise I wouldn't be repeating the same noise over, creating new noise. So if I want to retain the same noise, I can use call. I'm going to call this function with the input of the noise once. And so the list that's passed in should be the list that's also answered. I need to retain the ring here. So now what I'm getting is a table. I'm getting a list of 300 items of the same list. That is kind of random samples. So now what I want to do is I want to concatenate them all, flatten them into one big list. This is a new block in Snap 6, the append block. You can use it on several lists to concatenate them. And now I'm getting just one big list. And here's really the kicker. So this is all, just some random numbers repeated. And listen to this. You might, again, want to tune down your sound a little bit. It's a sound. It kind of sounds like a buzzer, but a complex sound, even though there is no sine wave involved and none of the things that we learned. It's really just repeating random things. And so this governs the length of our seed. So if instead of 200, I'm just using 100, I'm getting an octave higher. If I'm again having it, I'm getting another octave higher. If I'm doubling the original one, I'm getting an octave lower. So we can actually kind of do this to start our own venture into making music, into generating our own sounds. Now we've built this complicated function. Can we use it to do something else? What if instead of random numbers, we get a list here? A list of 4 items. The last item is 255. So now we're getting a table, and this looks pretty much like a picture. So what if we interpret this actually as a picture? So making a new costume, putting in this table, and I'm seeing the width here is 256, and the height is 300. I want to look at that picture, switch to that costume. So I just computed myself a new picture. It's a gradient. Back to white, because that's what these numbers do. So we can also slightly manipulate this and say, for example, 255, we're just inverting one channel, and we get a color gradient from green to magenta. We can put in a 0 here. We get green to red. We can place this someplace else and get different computed gradients and pictures. So the idea is that we can analyze media, we can do math with it. We can also change the context and create media ourselves. And this is kind of the vision, one of the visions that we're trying to accomplish with Hyperblocks. Now, another vision that is especially one that Brian is after is, actually utilize the whole power of APL. So the new version comes with this library that Brian has worked on that has all the primitives of APL And Brian is going to do a session on this, so come to his session also. So this is about really kind of reality, right? And one thing that's been bugging me is, and this has been a recurring theme really, the reality, the feel of reality of what we're doing with Snap about the blocks. And we're going to try something new, right, in the session. I'm going to switch here to the GitHub repository, go to Snap, and this is kind of a world new thing. Here's releases. The current release is version 6.0, and we're 107 commits farther. So we're just going to make a new release right now. It's going to be version 6.1.0. And it's going to have this description with it. Let's check it. Okay, looks legitimate. I'm going to publish this release right now. And there it is. And now I'm going to ask Michael to deploy it right now to the Berkeley servers so I can show you one more thing. Michael, can you hear me?
Right. It is. We're working on it right now. Let's see. All right. So we should be able to refresh, and it should be good.
I'm going to refresh.
See if the law of demos complies with us.
I'm going to click on Snap and see what's happening. And it is the new version we've just released. Okay, let me again open my slides. So there's just one new feature, and this has been a feature that back when I was working with Alan always said we should do this, and I did this for GP, and then somebody in the forums by the name of Low Clouds, I don't know if you're here, suggested that we added to Snap, and user Low Clouds in the forums also had another great idea. So here's one more feature. It is fade blocks. It's somewhat experimental. So when we fade blocks, I'm just going to open this also. Here's the animate feature. When we fade blocks, we can make the blocks less apparent. They get more transparent. The thing gets darker, and they're not in your face anymore. And at some point, and this was actually Low Cloud's idea, we're switching to the color of the blocks. And we can go all the way to the right until the blocks are all gone and just the text is there. And the idea really isn't so much to transition to text, but to take the burden, the visual burden of the blocks away. As you mouse over it, you can still see the blocks and kind of focus more on the narrative. I personally like it to be just kind of subtle like this. And to me, this looks kind of more like a programming language that adults could work on. And I'm hoping that people might be more happy with a less childish way of programming. And, there's actually some problem in there, because one of the aims of Snap is to be non-intimidating, to kind of have this message that this is actually child's play. But this is something that we're trying to do. So another thing that this corresponds with is, let's make a new project, is that, remember, we also have keyboard entry. So I can type in. So as I'm typing in, this also works kind of with the text mode. So I can do this. And I can just type in. Then as I start typing it, the blocks are shown to me. I can type in the script by just saying TU, and I can type in A, and I want to change A by 1. So this is all typing, and this is one way to maybe feel better and to have an individual way to use Snap in a way that looks more like your traditional programming language. Wow, folks, this was my demo. This was my talk. Did I make it in time? Time for some questions.
You did great. We've got about 13 minutes. I'm happy to handle any questions. I didn't see any that queued up in the Q&A chat that were directly needing your answer, but I'm happy to. Would you like people to just unmute themselves or raise their hand? It's up to you, Jens.
Yeah,
Your show.
should I just? I think I just stopped sharing, right? That's probably best.
Outstanding, folks. Before we handle questions, let's give Jens a hand. That was outstanding. Thank you so much. Woo! Wonderful, wonderful. Feel free to unmute if you'd like, or raise your hand. I can handle any of those things. I don't see any hands up. I'll try to manage this. I think there was some comment about people having to rewrite their curriculum. Thank you very much, by the way, from the point of view of all of us who have curriculum. That's outstanding. I see a question from Ken. When you choose the type of input, should one still choose number when it can also be a list?
That depends, Ken. So it's actually not yet a pervasive principle. We've just introduced hyperblocks to those blocks that otherwise would throw an error or give back something that you wouldn't want, like not a number. There are some functions, especially those that rely on testing equality, that we haven't yet hyperized. By the way, the name hyperblocks, that's something that's coming from Bernat. Bernat told us and found out that this was what they use in Perl 6. That was very helpful. So there are some functions like the equals predicate or the index of predicate, where we're testing for equality as we're also testing for structural equality. We're not using hyperblocks because that would change the semantics. So if you're using a block, if you're making your own block, I guess it's up to you to decide, should it also work? Are you using the primitives that all hyperize? Then your custom block will just automatically hyperize.
We have a question from Philip who asks, can we get a summary of what you did with the sound blocks and look blocks and a shared tutorial file?
So there is actually going to be a course that Yatka and I have worked on for the past months. It's called From Media Computation to Data Science, and it's an open SAP. It's free for everybody. Feel free to sign up. It's starting in September. It's got a little part of what I've just shown. And actually, most of what I've just shown you happened last night as I couldn't sleep and was so terribly excited about today that I just started Googling around and I found this Pink Floyd song and kind of did this stuff. And so, it was going to take me a while to write it up.
That's great. I think Yadu was mentioning that there's going to be a media computation course that you guys are working on. Do you want to talk about that for a second?
Yeah, that's the media computation course I just mentioned. It's going to be a 4-week course starting in September. Had we known that 4 weeks is so much work, I think we did a 2-week course. But we wanted to try this kind of new thing that we've been really working on for the past kind of 2 years, really, where we kind of go beyond introductory computing. Because kind of we feel like we've done kind of this introductory computing, get people excited about doing things, and we want to take the next step because there's so much interesting things we're bursting to show you. And so this is really our love for media computation was something that we try to have the proof of the pudding by saying, this is exactly the same thing, the same ideas that we need to analyze data, to do some interesting analysis. So this is what the course is about. All the materials in the course are Creative Commons. Everything is free to make and to use. Even if you don't take the whole course of your teacher, just go and take what you need, and you'll find some. It's 20 fun games, 20 fun activities, the kind of that I've shown you just here.
I have a question. I'll just add myself. I'm looking. Feel free to continue to ask questions in the chat. Are there other features of 6.1 you want to mention? I saw that you pasted in about 30 things, 30 bullet lines. Other things we should look for in 6.1?
Well, no. 6.1 is basically a bug fixes, it's really just this one thing, and it turned out to be bigger than I thought. I think I mentioned in the forum, I thought like I could do this with just one line of code. Turned out I couldn't. So I keep kind of totally failing the estimate of what it takes to build something. No, this is the one new feature. There's another important feature for anybody of you who's working on forks of Snap. I've added a little documentation how you can migrate your forks like Beetleblocks, Turtle Stitch, to the new Morphic version that's way more stable and way faster.
Very useful. Looking for feel free, folks. Other thoughts? I have one more that is in the back of my head. One of the things I love about Snap 6, at least, is that it's almost real time. The frame rates are approaching 4, 5, 6, almost 10 frames a second if you're just taking a screenshot and then displaying it, and then without doing any computation on it. What do you think you're up to? Is it about 5 or 10 frames a second? It's really very quick. I mean, when you were doing the two eyes and the thing, it was very fast, much faster than I've ever seen in Snap 5. So what do you think you're up to?
I don't know. It depends, I guess, how big your picture is and how much computation you're doing. Because remember, every block you stack inside means one more iteration over the whole list. Right. Now, the reason we can do this fast is because it's not a replacement for a higher order function. It's not a replacement for map. It's only a replacement for certain uses of higher order function. Where, if you're using +3 on every item in a list, we know that this function will terminate. We don't have to do all this overhead to let the user click on the red stop button to stop it, like if there's no base case in some recursion or if there's an infinite loop, because we know it can't happen, which is why we can do it very fast at the low level. And that's kind of the beauty of Hyperblocks. We felt that, we're going to do this thing, it's got to be fast. Because it's one thing to always kind of boast with how expressive it is, and then people come and code it up in some imperative way and say, well, but that's way more faster. So we thought, if we're going to do this one level of abstraction, it better be really fast. And I'm kind of glad that it actually turned out this way. It's now faster to do it with Hyperblocks than to do it iteratively.
Wonderful. I'm looking for other thoughts. People
I've got a question.
Go ahead, Ken. Yeah.
Given what you just said, I'm wondering if there's coming in the future, something would take advantage of the GPU when you're actually doing lots of linear algebra. You could speed it up several times, and it's right there in the browser.
That's mid to long-term vision. So the current kind of redesign was really to what we had right now kind of technically was we pre-rendered everything, and that took up a lot of memory, so it was faster to just redraw it when we need it just in time than to pre-render and cache it. Now the idea to really be faster is to make use of the GPU and to make use of multi-cores. And that is something that, since we're building on top of JavaScript, it's just slowly happening at the browser level. Something called web workers and something called right. Off-screen canvases. And once we get to actually play with that, the idea would be to have actual concurrency, to have real kind of threads, hardware threads actually, in the future. It's something we're looking closely at, but don't hold your breath. I mean, maybe when it happens widely in JavaScript, we'll be able to use it, of course.
And do stay tuned for the last session on Sunday, where we're going to be talking about the future of Snap. There's a future of Snap panel. I just want to put a plug in for that. So a lot of these questions might be, what do you want to, what's next? What's next? I think that'll be a whole session where the folks will do that. And that was one of the highlights for me of last year's SnapCon. Wonderful. Other questions? We're doing great. We're about 3 minutes left. What a wonderful session this was. People were thanking you for the documentation on migrating extensions. So that was a big one. Big thumbs up there. I can see Bernat nodding and other folks nodding for that. We really appreciate that. That's something that we've needed. Thank you again for that. Let's see, I'm looking for, hyperized inline if. Michael is being snarky and asking for that.
No, it's an excellent question. It's actually a funny question because it's kind of the thing that comes to mind. Like, of course, it should work. And the funny thing is, I actually spent a weekend writing it up, and it did work, but not in the way like it did something, and I felt like it was doing something wrong. And then I looked at it and said, oh, well, it's actually doing the right thing, except I had misconceptions about it. Our thought was that, we could use, for example, a recursive declaration, a recursive definition for, factorial, and just use it on a list of numbers and get back a list of factorials. Instead, what we got was this really complicated nested list of lists. And so if you look at it, it's actually right. It's probably something that if there are control structures involved, that we might think about having extra blocks, that it might just not be the right thing to overload the existing ones if they're either testing for equality or if they're control structures.
All right. Other last questions? I think I have about 40 seconds left. We then have a gap of 40 minutes before the short talks start then. So do please take a break, stretch your legs, get some food, walk around, or continue to talk. By the way, as you know, there's a hallway. You can always drop in. So please do drop in the hallway to just have a chat if you're wanting to meet other folks. Looking here. Oh, maybe I should pull up the schedule. Michael's suggesting I pull up the schedule. Let me see if I have that really fast. While I'm doing that. All right. I'll try to pull the schedule up. Let's give Jens a hand one last time. Thank you so much, Jens. Wonderful.
Not worthy.
What a great way to kick off SnapCon 2020. I'm so happy. Delightful. So take a break, everybody. I'll pull up a schedule. I'll drop it in. I'll share the screen, and we'll all stretch our legs and take a break. Thanks again, folks. Take care. Thank you, Jens. I was outstanding.
I'll just share the schedule if anyone is...
That'd be great, Michael.
There, but
yeah, perfect,
main thing,
perfect.
The light green, just like the operators, are the hallway tracks. So we'll end this meeting in a few moments, but that's where we can all hang out for the next 40 minutes. And that will be open all day long, but the next session starts at 11 Pacific time. Also, anywhere you see a timestamp on the website, you can go ahead and click on it, and you can view it in your own time zone. A little bit of a hack, but
that's nice. 10:50. You said 11. It's 10:50.
10:50. Yeah.
Yeah. Don't be late.
All right.
Thanks, everybody.
Yeah.
Good to see you all.
All right.
Yeah, it's outstanding, my friend. Outstanding.
Thank you.
That's great.